Hello, welcome to everyone in this video. This is lecture number 13 on digital electronics. Today we want to discuss counter. In this you can see the asynchronous counter, that is ripple counter, decade counter, and synchronous counter, that is ring counter. So let's start. You can see this is the syllabus in integrated circuit, number system, digital circuit, then implementation of different circuit, data processing circuit, sequential circuit, and register already discussed in previous lecture. Today we want to cover up this counter. In upcoming session we will be cover up also computer organization and data conversion. So let's start today's discussion, that is counter. Counter is a sequential circuit. You know, if you attend the previous lecture, you know about the sequential circuit, which depends on the previous output and the present input. So this is a sequential circuit, sequential circuit that generate that a predetermined binary number sequence over and over again, over and over again. Okay, this counter have three types. If you want to know about the types, there are three types. Number one is asynchronous, synchronous. Number two, synchronous, and number three, hybrid. In asynchronous, the example is ripple counter, decade counter, and synchronous counter example is ring counter. So we want to discuss about the ring counter, ripple counter, and decade counter in the upcoming. Before that, we need to explain, that is asymmetric and asynchronous and synchronous counter. What do you mean by asynchronous and synchronous counter? We can tabulate them as, that is synchronous counter and asynchronous counter. Synchronous means all these flip-flop triggered by a single clock. This flip-flop, mainly JK flip-flop or D flip-flop, flip-flop 3, flip-flop 2, flip-flop 1, flip-flop 0. All the flip-flop triggered clock are triggered by a single clock, and this is S triggered clock, not level clock. You know, in level clock there is a problem in race around condition. So these clock are connected with each flip-flop. That means they triggered at the same time, and these inputs are like that. So these are connected here like that, and this is this one. So this is the synchronous, where the clock are connected to each flip-flop. That means they are triggered at the same time. But in asynchronous counter, with respect to clock, we can say flip-flop 3, that is the output. Clock is connected with one and this output is a clock of another one, like that. That's mean here you can say all flip-flop active with same clock pulse. But asynchronous counter, they are not active in the same clock pulse. They are different clock pulse. Different clock pulse. Different clock pulse. Right? Since actually in the asynchronous counter you can make only up or down sequence. Uh, can make up or down sequence. Up means 0, 1, 2, 3, like that. Down means 3, 2, 1, 0, like that. But in synchronous counter you can make any setup, up, down, random, etc. So can make up, down, random, etc. Okay. In synchronous, so since these are triggered by a single clock, so this is faster. This is faster. Comparatively, this is slower. Not very much slower, but comparatively slower. Comparatively slower. And this, as this is required more gates, is a complex design. So this is complex design. This is comparatively simpler design. This is comparatively simpler design. Okay. So this is high cost and this is low cost. Because this is complex design, that's why this is high cost, this is low cost. Okay. Here the example of synchronous is ring counter and the example is the ripple counter, decade counter, etc. Okay, so I think you understand about the synchronous counter where the triggered by the single clock, but in asynchronous counter the flip-flops are triggered with different clock pulse. That is the asynchronous. Now we need to understand some basic things, that is the mode value of the counter. What do you mean by mode value? Mode value of a counter. What do you mean by mode value? Mode value is the number of different state. Mode value is nothing but the number of different state. Number of different state is the mode value. For example, you have states 0, 1, 2, 3. If you change the clock pulse, it repeats like that. After 3, this will become that one. So the mode is 4 here. Mode value 4, because there is 4 different states. Here, if anyone can ask that after 17 clock pulse, 17 clock pulse, which will be the state. Initial will be like that. This is the initial will be state. So if you divide it by 17 by 4, here is the remainder 1. So after 1, 2, 3, 4, after 4 pulse this is 0. So after 16 pulse this is also 0. So after 17 pulse this must be 1 state. Clear? I think clear. Next you need to know about, that is the number of flip-flop required. Number of flip-flop required to design mode n counter. For mode 4 this is mode n. For mode n counter, what is the minimum number of flip-flop required? Actually you know, for a state, binary state 2 to the power n, so you can say 2 to the power n greater than equals to m mode. So n is nothing but log to m, right? For example, you wants to get 4 mode. So if you put 4 here, so n must be 2. So you need to require 2 flip flop. Okay. But remember something, that is, as the sequence is 0, 1, 2, 3, and you know for 3 you need to represent, that is the 2 and 1, 2 and 1, this is 1, 2 and 1, that is 3. So okay, so here the two flip flop can make this output, but you have suppose 0, 1, 5, 3 like that. So for making 5 you need take 4, 1, so you required minimum 3 flip flop. Here required 3 flip flop. Okay, so for without state, if you have a state value, then you need to know about this formula, and if there is any state where required more number of flip flop than this, then this will be the answer. Otherwise this is the formula, you can use this formula to get the number of flip flop required to get mode n counter. So up to that point you understand about the synchronous counter, asynchronous counter, and the mode value of a counter and number of flip required to this counter. Now you need to know about, that is the up and down counter. What do you mean by up counter and what do you mean by down counter? Up and down counter. So you need to know about the up counter and down counter. Up means the sequential value change from 0 to upper value. Up counter means is a sequence that is 0, 1, 2, 3, etc. This is the up counter. And down counter means 3 change to 2, change to 1, to 0. This is the down counter. Now, how you will be get up counter and down counter? You know, the counter is like that. There is a flip flop, JK flip flop, etc. But there is a clock. Important thing is clock. This flip flop will be this is flip flop. Flip flop will be JK flip flop or D flip flop. Flip flop will be JK flip flop or D flip. Okay, but important thing is the clock pulse. This clock pulse and this Q value depending upon, you will be get up and down. For example, this is the Q value, so this is the Q value, there will be positive value or negative value, and the clock pulse will be positive. This is the symbol of positive clock pulse, and negative is this one. So positive means positive. If the same state, then down counter, and opposite state, you will be get up counter. So these are the same, so you will be get down. These are the opposite, so this will be up. These are the opposite, this will be up, this will be down. So using this simple concept, you can get the whether this counter is up counter or down counter, just taking the consideration of the clock pulse and the Q value. Now the important thing is the asynchronous counter example, that is the ripple counter. Ripple counter is the asynchronous counter. Synchronous counter. Special type of asynchronous counter where one clock pulse is applied and all the others clock pulse taken from the previous output. Only one clock pulse is applied. Only one clock pulse is applied, and other clock pulse taken from previous flip-flop output. Okay, this is the basic of ripple counter. Here use the toggle mode. Here use JK flip-flop toggle mode. You know very well about the toggle mode, that is J equals to 1, K equals to 1 state. Okay, this is the basics, important things of a ripple counter. So if you wants to draw the circuit with the flip-flop 4-bit counter, this is JK flip-flop. All the JK flip-flop. Flip-flop 3, flip-flop 2, flip-flop 1, flip-flop 0. All the JK, and this is toggle condition, that means these all the inputs are 1, so just connected them with a high voltage one. So this is toggle condition. Now here we apply a clock pulse. The output of this is as a clock pulse of second one. This output, suppose this is 3, this is 3, this is Q3, 2, 2, Q2 is the clock pulse of this is 1, 1, and this is Q1, 0, 0, this is Q0. Right, so the output of that one is the clock pulse of that one, and so So the clock or all the flip flop is not that are not the matches or the synchronous, that is the asynchronous counter. Okay, now if you count anything, suppose just think, you have this clock pulse. This is a clock pulse, just considering it the same width. And taking this is positive triggering. Positive triggering is when change from 0 to 1, this will be the change. So the Q0 will be changed like that. When this is 1, then again change. This is 1, then again change. This is 1, then again change. So on, then again change. Right? This is positive triggering. Change and so on. For Q0 is the input of Q1. Actually, this is Q3. This is Q2. So this is triggered here, and then it is triggered here, triggered here, triggered here. Now for Q1 positive triggering, so triggered here, then triggered here, and Q0 for this one, this is triggered here. So you can see the value, that is 1 1 1 1. This is 1 1 1 1. This is 0 1 1 1. 0 1 1 1. This is 1 0 1 1. This is 1 0 1 1. This is 0 0 1 1. This is 0 0 1 1. This is 1 1 0 1. Like that. So using this clock pulse, how many numbers is actually obtained, you will be get the value. If you take the negative clock pulse, for example, if you just take negative triggering, you will be obtain this number. Actually count the number of digit, then you will be obtain the actual value. Just taking the negative triggering, then you will be able. So this is triggered, that means this is 0, this is change, negative triggering, 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 this also change, negative, change, 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 and so on. For this one negative, so this here change here, negative changed here, negative changed here, negative changed here. This is negative, so this is changed from here and changed from here, and this is changed from here. So you can see this is 0 0 0 0, and this value is nothing but 1 0 0. This is 1, this is 0 1 0 0, this is 0 1 2, this is 0 1, sorry, this is sensitive, 1 1 0 0, this is 0 0 1 0, this is 1 0 1 0, right? 0 1 1 0, 1 1 1 0, right? So you can see how this count the signal which are passing. So this is ripple counter where the clock pulse are asynchronous. Next important thing is the decade counter. Decade counter. Decade counter is the count the decimal number. Count decimal number. Okay, it's count decimal number. To count the decimal number. Decimal means up to 9, 0 to 9. So for that, you know, for 2 to the power 3 you will be get 8 only. So now you need 2 to the power 4, 16. But you did not take 16, you take only 10. Okay. So here you need 4 flip flop, that is 4 bit. There is 16 state, but required 10 state. So that's why it's known as the modified 4-bit counter. This is modified 4-bit counter. So you need to modify it, this signal. Here actually this, you know, in this there is output is Q3, Q2, Q1, Q0. These are the bits which are used for counting. This 4-bit actually, when just taking the truth table, you will be understood very well. This is the clock pulse. This is Q3, Q2, Q1, Q0. For the initial state, this is 0. For clock pulse 1, this is 0, 0, 0, 1. 2, 0. 3, 4, 5, 6, 7, 8, 9. And after that, for 10, it will be repeated this one. You need to repeat that one. So you can see the that this Q3 and Q0 are after that. Actually for next state, this becomes 0, 0, 0. So next state was 1, 0, 0, 1, 0, 1, 0. Next state is 1, 0, 1, 0. This must be changed into 0, 0, 0, right? Next state 1, 0, 1, 0. This is must be changed into 0, 0, 0. So this is changed to 0, 0. That means these two are and these and are need to clear. So Q3 and Q1, this is Q1 and this is Q2. These two are ended up and then clear with clear. So this is the actual modification. So just taking a diagram. This is the 4 flip flop, flip flop 3, flip flop 2, flip flop 1, flip flop 0, and the Q1 and Q3, Q3 and Q1, which are ended and clear to the circuit. That is, it's clear. This is clear button. Clear, clear, clear. This is clear button. So these two are ANDed and clear the circuit. Actually Q3 and Q2 is not, actually you need to take Q2 and Q0, right? Because these two are 0. Q2 and Q0 are 0. So you just AND it and then, and the other things are like that. So this is the that one. So this is similar, only these things are different. And you know the JK are the same things, toggle condition. So these are the one. Okay. So this is the decade counter where you actually count from 0 to 9. It's 10 digit. Now important things is the ring counter. What is the ring counter? Ring counter. It is a synchronous counter. It is a synchronous counter. Synchronous counter means here all the flip-flop acted by a single clock pulse. All flip-flop connected with single clock pulse. A single clock pulse. That's mean here actually use generally D flip-flop. D flip-flop generally used here. Clear? Suppose this is the flip-flop 1, 2, 3, 4. This is a D3 corresponding Q3, D2, Q2, D1, Q1, D0, Q0. Here Q3 connected D2, D2, D1, and this D0 is connected here. And all the clock pulse is connected with a single clock. This is the clock. Okay, so this is the basic of ring counter. They are synchronous, all the clock are connected to the same clock, and there is a make a ring. That's why this is called ring counter. Okay, now if you wants to understand, that is the Q3 is nothing but Q3 n plus 1 is nothing but D3, and this is nothing but Q0n. Similarly Q2 n plus 1 is nothing but D2, because you know in D flip flop just just transmit the data. So this is Q3 n and so on. For example, if you taking another example, Q3, Q2, Q1, Q0, at the initial this is becomes like that. Suppose this is the initial value. After this is transfer, and this transfer and this transfer to that one. So you'll be get 0, 1, 0, 0. Then it's transfer here, it's here and this here. So this is 0, 0, 1, 0. And after that this here, this here, this here and this here. So 0, 0, 0, 1. Again it's repeats here. So this here, this here, this here and this here. So you'll be get initial state. So finally you will obtain the 4 state. Here the 4 bit means 4 state, that is mod 4. There is a 4 state. But you know 4 flip flop means 2 to the power 4, that is 16 state available. 16 states available. 16 state available, but only 4 states used. So on usable states is 16 minus 4. So in general you can say this is 2 to the power n minus n is the unusable state. Unusable states. This is the unusable state. 2 to the power n minus n. So I think clear about this counterpart. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact details. This is my YouTube channel details. So thank you. Leave me to next video as soon as possible. Thank you.